My name is Nawanga Afwa, and I'm going to take you through the MLOPs deployment for our bovine respiratory disease detection project. Basically, we decided to use a proximal policy optimization model. That's in simple terms, it's a reinforcement learning algorithm. Due to its simplicity and strong performance, we decided to use it over other models. So basically, to start with, we use Flask app from the beginning of the deployment, and basically this is our GitHub. Then to go through it in simple terms, we have templates. These templates basically it's simply a folder where we find our HTML files. Then for this requirements.txt is it's where we get all our Python dependencies that we are going to need in during this deployment. Then for this app.py, it's basically the main Flask application containing all the logic and the roots. So to go through this code that we used in our deployment in simple terms, we have as you can see, import Flask, the pandas and NumPy. The pandas and NumPy, these are basically for data processing. Then the Flask, just like I said, it's the main thing here. Thus, it's used for web application. Then to continue, you can see we went ahead to import gem, and gem import spaces. So basically, this gem it's used for it's the main thing that we use for BRD detection. So if we continue, we can see the num features such as the data.shape being a 0 or 1. Then for we have this render template. This render template basically, in simple terms, it renders HTML templates just like I showed you earlier. It goes ahead to render HTML just like you can see in these brackets. We are seeing index.html. So basically, it renders our HTML files. Then if we are continue, we can see app.root.train. This basically trains the model, goes ahead to train the model. We are going to see earlier on in our when our next presenter goes ahead to present, we are going to see how it goes ahead to upload a file during the training session. Then we can see this app.root, then hash predict, the /predict model. This is basically for prediction. Then this we can see if not os.path.exist brd model.zip. So basically, this brd model.zip, it's a zip that saves the trained model. So this is where the trained model is saved. Then for the model.predict, it goes ahead to do the prediction part, whereby if it's a 1, it basically shows an intervene. Then if else, or maybe if it's a 0, it shows that no intervention needed. So to lastly but not least, we can see this app.run, then host then the port. Then basically it shows that the Flask app is running on this port. Then this debug is equal to true. It goes ahead to show that there is debugging taking place, meaning when debugging takes place, there is easier deployment. So basically, haven't I talked about? That's it. Then we, after having this code, went ahead to the cloud that we used. It's the render So we went ahead to come to our render and went ahead to deploy the model. We came here to manually deploy. Then yeah, we went ahead and clicked on clear build cache and deploy. Then this was our result. Then after our deployment, yeah, then we went ahead and the moment you click here, it basically takes us, yeah, it takes us here. This is where we are going to go ahead and train the model from and predict. That's where my
Hello, my name is Dumayan and I'm going to run you through our code for our model to detect bovine respiratory disease at the early stages. So we deployed our model using Flask, and this is our code as my colleague explained below. So I'm just going to run my models. So I'm going to use port 8000, and so let me just pass you through a few comments. So here we have a function for the environment, and we're using gym environment OGYM, and here we have our render template, and this is where we train our model so that it can allow and uh, string data types like as numerical data types, and here uh, lastly we have our predictions made, and through our template we have different inputs as I'm going to show you. So let me first run my app quick and we see. So let me, okay, this is module and Python app.py. Taking a bit longer, so it has given us these ports. Let me run them. Okay, it's running. Okay, here it is. So this is our interface that we have so far. So if we choose our data set, we have this file. So it is now training. So and after training it will show us that it's done training. So as it's training below, like in the VS, since I'm running it locally, so it is doing iterations behind so that it can train using that data set. So it is doing iterations, iteration one, iteration two, many iterations through the data. So and then when it is done with its iterations, it will give you the feedback that it has done training. So here I think it's done training, and yeah, it has given us a feedback that it's done training. So I'm going to just feed in a few. So let me just show you a preview of our data sets. So we have here some data, and we have the temperature score, blah blah blah, cough, discharge, eye discharge, yeah. So very many. Is the cattle lying down? Is it laying down daily? Is it moving? And many other. So this is just a few of what we are going to be using for this sampling. So let's say gender, it's female, and also discharge normal, eye discharge, maybe it's worse, maybe yes, and also maybe this one is normal. Let's say the score is 3 and weight 55, and how many times is it lying? Yeah, like daily. Let's say, okay, let's take it like for a week. Maybe it lies like 30 times. So it has given us our prediction that we should intervene. Maybe this cattle is infected. We should go and check it out. So this is how this model can help us to know the health status of our cattle. So thank you.